Day 8. We are shifting gears from solving systems of equations, and now we are moving towards graphing systems of inequalities. And that's what you have here. The shading represents inequalities. We're less than this, we're greater than that. But first, let's talk about how to tell if a given point is a solution to the system. Basically, if the point falls within the solution area, if it's in the shaded zone, then it's a solution. If it falls outside of the shaded area, if it's not in the solution area, then it's not a solution. So a point in here, solution, out here, not a solution. So the only part that's even slightly ambiguous is what happens if it's right on the line. Well, if it's right on a solid line, then it will be a solution. Okay, so this blue point right here, we would say yes. So this would be a yes, while this would be a no. And this would be a yes. This is just like some notes for you. Alright, so yes if it's in the shaded area, yes if it's on the line, if it's a solid line. No, it's not a solution if it's completely outside. The only thing that will change that is if it's a dotted line. So this, for example, would not be a solution. This would be a no, because the point of having a dotted line is you're saying this line is not included in the solution area. The solid line is included, so all of these points are solutions. But the dotted line is not part of the solution, so all of these points, like this one, would not be solutions. Okay, obviously I was just making up random points, so let's erase and start over. So the point 0, 1. 0, 1 would be right here. And so that's clearly inside the shaded area, so we would say yes, that's a solution. Okay, 3, 2. Alright, be careful. You see this little 2 right here? They're trying to tell you that these squares are counting by 2's. So this is like 2, 4, 6, 8. Okay, so with that in mind, okay, so this would be 2, this would be 4. So this is 3 is halfway in between. So 3, 2 would be right here. Just be careful. And again, that is within the solution area, so we will say yes, that is a solution. Let's see, how about the point 5, 2? 1, 2, 3, 4, 5, 2. Well, this point is right on the borderline. And because this is a dotted line, then we will say no, that is not a solution. If this had been on a solid line, it would have been yes. Alright, let's move on. Alright, look at number 4. Graph the following inequalities. Well, in order to graph it, we are going to need to rewrite this into slope-intercept form, like y equals mx plus b. So starting with the 3x minus 4y is greater than 12 business, we have to get y by itself. So we would subtract 3x from both sides. But if we do that, we have negative 4y is greater than negative 3x plus 12. Now we have to divide by negative 4. Okay, so when you divide by a negative, the one thing you have to watch out for when you're dealing with inequalities, if you divide by a negative number, you have to reverse the direction of the inequality. So because we are dividing by negative 4, this is going to become y is less than 3/4 x minus 3. Okay, notice I put positive 3 over 4. A negative divided by a negative is a positive, so cancel those signs out. But so this has gone from greater than to a less than, so please watch out for that. Now we're ready to graph. Remember, sometimes when we graph these lines, they will be solid lines, like this, and other times they will be dotted lines, like this. Alright, they will be solid when we have greater than or equal to, or if we have less than or equal to. If it has a little equal to part to it, then it's a solid line. If it's just greater than or just less than, then you've got dotted line. Okay, so this is just greater than, so well, this one is just less than. So this will be a dotted line. Now, as we go to graph it, we start at -3, because that's our y-intercept, and we go up 3 over 4. Up 3 over 4. Alright, down 3, back 4. Repeat. Alright, and now we need to draw a dotted line through here. Okay, so we'd have this. Now, when it's an inequality, in addition to just having a line, we can reflect the inequality by shading. And I encourage you to think of this using these two words, above and below. Above and below. When you see a less than sign, if you look at this and you think, okay, this is definitely less, which one of these words matches with less, above or below? Below, okay? Below is clearly less. So if you have below, that's going to be less than. If you have greater than, that's going to be above. So in this case, we have less than. So as you look at this, you should be thinking, okay, we need to shade below the line. We add that in. This is below. So it's like this. If I pick any point on the line and I go straight down, then I'm going below the line, below. So that tells me where to shade. This side of the line is the side that is below the line. Okay? And that is how you do number 4, including the shading. Very important. Okay, number 5. Similar, very similar. We have to get y by itself. So we're starting off with 8x is greater than or equal to 2y minus 15. Alright, now let me tell you something. This y needs to be on the left side. So if I were you, the first thing I would do is I would reverse this entire equation, inequality. Just write it backwards, okay? So I'm going to put my 2y minus 15 over here on the left, and I'm going to put my 8x on the right. Okay? Put your y on the left side for these. Now, we just have to put the symbol in. Remember that the open side was facing the 8. Alright, because we were saying that the 8x was greater than. So when you redraw it, you're going to have to write it this way, so that the greater end, the open end, is still facing the 8. Okay, I would do that first if I were you. Then I would continue on with the problem. So add 15 to both sides. So that's going to give you 2y is less than or equal to 8x plus 15. Okay, then you divide by 2. Do I need to reverse the direction of the inequality? I'm dividing. No, really I do not. I do not need to reverse the inequality because I am dividing by a positive number. You only reverse the inequality when you're dividing by a negative number. So this will be 4x plus and what is it, 7.5. Okay, so let's graph this. So the y-intercept is 7.5, which would be right here. Okay, and then the slope. For the slope, I'm supposed to go up 4, right 1. Alright, there's not really a space for me to go up 4, right 1. So I'm going to pretend that I did that. Okay, that would be like 1, 2, 3, 4, right 1. Okay, fine. But then to go the other direction, then I would have to go down 4, back 1. Maybe I should put this a little more. Yeah. So in backwards, I'm going down 4, back 1. So I'm just going to continue that. So 1, 2, 3, 4, back 1. Okay, they should all be between the lines. 1, 2, 3, 4, back 1. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. Okay, now this is or equal to, so this should be a nice solid line like that. Now the shading. When you look at this symbol, you should be thinking, oh, this is less than, so this is going to be shaded below the line. Okay, so similar to last one in terms of being below. So again, if I pick any point and go down, then I'm going below. Below, 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 below. Okay, and then so the rest of your shading should be on this side as well. Alright, and depending on how much time you have, you can do a better job coloring than I did. But that's the idea. Okay, let's move on to number 6. Now, number 6, we begin to have more than one equation at the same time, so let's be careful. Okay, we still have to get y by itself in both cases. So if I have x minus y is greater than 7, alright, I'm doing this one. I would have to subtract x from both sides. Now, watch this. You see I still have this negative sign in front of the y. I have to get rid of that, and I can do that by dividing everything by -1. Alright, but I'm dividing by a negative, so I'm going to have to reverse the inequality. Okay, so I've got this. Let's go ahead and graph this one. So that's going to be -7. And then up 1, right 1. Okay, and this should be a dotted line. And this is less than, so looking at this less than sign, you should be thinking, okay, less means below. So that's where we will do our shading. And this is the below side of the line. Down, 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 below, below, below. Okay. Oh, wait. Oh, I messed up a little bit. Okay. Start over. I didn't do anything wrong, but I forgot for a minute that we are graphing two equations. When you're graphing two equations, I do not want you to shade in the whole area. I just want you to shade one small band of it, like this. Don't shade in the whole thing until the end. And you'll see why in a second. So let's move on to the other inequality, which I will do in red. Alright, you guys, I'm starting to lose my voice. So just watch what I'm doing, but I'm going to have to do less talking, okay? Alright, so y is by itself. I didn't have to reverse anything. So let's graph it. Alright, slope is like negative 2 over 1. And again, this is a dotted line. And like I said, we're going to shade below. But once again, do not shade in this entire area. Just shade in one small band on the below side of the line. Okay? Because the solution area is only going to be one of these four regions. Let me see if you can guess which one it is. Alright, is it going to be zone 1, zone 2, zone 3, or zone 4? Which one of these four is going to be the shaded area that's actually the solution? Alright, hopefully you said zone 4 down here at the bottom. And the reason is zone 4 satisfies both inequalities. The shading helps you see because zone 4 has the shading from both. That means it's below the blue line like it's supposed to be, and it is also below the red line. So this is the only zone that I want you to go ahead and shade in completely. The other areas only get a band. Okay, so that is what number 6 should look like. Alright, number 7 is almost the same thing. And again, I'm going to do as little talking as possible. So this is what the line should look like. Now I'm going to shade above, but not the whole thing, just a tiny part because there's another line coming. Okay, now let's do the other one. Alright, make sure that when you do this, because it's negative, I'm going to go down 1, right 1. And this should be dotted, and it should be below, alright, because it is less than. So the line would look like this, and like I said, we're going to shade below. But whenever there's more than one line, do not go crazy and shade everything. Just shade one band on the correct side of the line, like this. One band. Alright, now, which zone is the actual solution going to be? Zone 1, Zone 2, Zone 3, or Zone 4? I hope you said Zone 1, brothers and sisters. You see all the shading? We're below the red, above the blue. It has the double shading. So Zone 1 is the solution region. Okay, so number 7 should have looked something like that. Alright, number 8. Please remember, when you look at equations like this, you should be thinking about, inequalities like this. You should be picturing the equation version of it. And I'm hoping you remember that y equals a number is always going to be a horizontal line. Okay? So this is going to be a horizontal line at 1. So this red inequality is going to be like this. Alright, we still need to do the shading. This is going to be a solid because of the equal to part, and it's going to be above because of the greater than part. Okay, so, well, alright, we already had the solid, but it's going to be above. So again, just put a small amount of shading above the line, like this. Similarly, the next one, this little guy, you think about the line x equals 6. And hopefully you remember that x equals a number is always a vertical line. So it should be like right here. It is also solid because it's or equal to. Now, because this is less than, normally we would be thinking below. Alright, but that's for y values. Y values are above and below. This is the one time that you have to think left-right, because x values go left and right. And of course, the lesser x values are to the left. So this is the only time that we think left-right, when it's a vertical line. Alright, but you should put your small amount of shading on the left side of the line, just to remind you of what we have decided on. Okay, a little bit of shading to the left. We still have one more equation to do. This one's a triple. Okay, so we'll do this one in purple. It's already in the right form, but this will be below, alright, because of the less than, and it will be dotted, alright, because it doesn't have the or equal to part, so be careful. So we have start at -5 and then go up to right 1. Okay, now I'm going to draw my dotted line. So that's going to look like this so far. Now it's time to do the shading below. So I will put just one small band of shading below the line. Okay? So there are several zones that you have to pay attention to in terms of where the solution could be. So please be careful. Alright, is it going to be zone 1, zone 2, zone 3, zone 4, zone 5, zone 6, or zone 7? There's 7 possible zones, but only one of them is right. Which is it going to be? Hopefully you said it's going to be zone 4. Zone 4 is the only region that satisfies all 3 inequalities. It's above the red, it's below the purple, and it's to the left of the blue. Alright, it's the only zone that had shading on all sides. Alright, let's look at number 9. Alright, same type of thing. So let's get y by itself. Let's do the red equation. Okay, so on this equation I would have to subtract x from both sides. So that's going to give me negative 4y is greater than negative x. But then I would need to divide by negative 4. Okay, be careful. I just divided by negative. That means I need to reverse the inequality. Now, this is like there's an invisible 1 here. So this is going to be 1/4 x. Notice the negatives cancel out. Alright, there's no visible y-intercept. That means you start at 0. And you go up 1, right 4. Whoops, miscounted. Okay. This is going to be a dotted line because it's not or equal to. And this is going to be shaded below the line because it's less than. So again, there are multiple lines, so do not just go crazy shading all this in. Just shade in one band below the line, like that. Alright, let's do that 2 more times. This time I'll do blue. Remember, this is like x equals 1. So that's going to be a horizontal line. Sorry, I said horizontal. I'm in a vertical line. X equals 1. X equals the number is always a vertical line, just like last time. And it's going to be shaded on the left side because of this less than. For x values, the lesser values are to the left. Okay, just give it a small amount of shading, please, not too much. Okay, one more. And I will do it in purple. Alright, so the purple line goes x, subtract, divide. Okay, so this is the equation that we have to graph, inequality. So we'll start at -1, and then go down 1, right 3 from there. Okay, this will be a dotted line because no or equal to, and it's going to be shaded above because of the greater than. So I'll put a little bit of shading above the line. For this one, the solution area is so tiny that it's going to be hard to see. Maybe I made my band too thick. Because look, I'm going to color the solution area in black so you can really see it. Alright, the solution area is this tiny triangle because that's the only one that satisfies all three zones. So it's really just this area in here. Okay, this is the solution. The little black triangle. That's it. Okay, we should do that here too. This was the solution back on this problem. Okay, do whatever you have to do to make it visible. Okay, we just have two more problems.
Alright, so let's start with this equation. So we're just going to have to break this down. So this is 5x minus 3y is less than or equal to 6. We need to get y by itself. So we need to subtract 5x from both sides. So that's going to give us negative 3y is less than or equal to negative 5x plus 6. Now we need to get y by itself. So we are going to have to divide by negative 3. Now be careful. We're dividing by a negative number, so whenever you divide by a negative number, you must reverse the direction of the inequality. So it's going from a less than to a greater than. Okay, minus 2. So this is the new equation that we're going to actually graph, inequality. So we'll start at negative 2 because that's the y-intercept, and we will go up 5, right 3. And we can do that a few more times. Okay, I think that's all that's going to fit. Because it's or equal to, this is going to be a solid line. Because it's greater than or equal to, we are going to shade above the line. Now, because we have multiple inequalities coming, we're just going to shade a little bit of it above the line. We're not going to go crazy with it. Okay, I'm shading above, but just a little bit. Got to leave space for the other lines. Okay, now let's switch over to red so we can keep track. So the red equation is x plus y is less than 8. Subtract x from both sides, so we have y is less than negative x plus 8. Alright, well that wasn't too bad. So we'll start with 8. And we will have to go down 1, right 1 because of the slope. This one is going to be a dotted line because it does not have the or equal to part on it. It's just less than, not equal to. And because it is less than, we are going to shade below the line. Less than tells us to shade below the line. Okay, and again, I'm just going to start by shading just a small amount below the line. All right, don't just shade everywhere. All right, we won't go crazy until we see the final line. So now this last graph, y is greater than 3. Okay, y is greater than 3. When I graph that, in the back of my mind, I'm picturing the line y equals 3, which is a horizontal line at 3. Okay, so here's 3 right here. This also will be a dotted line because it does not have the or equal to part. So this is the purple equation. Okay, and because this is greater than, we will shade above the line. So I'm going to put a little bit of shading on this side, like this. Okay, now I'm looking for an area that is completely surrounded by shading. All right, it's kind of hard to find. Let me change colors. But if you look in this area right here, see how it is completely surrounded by yellow. All right, this area has yellow on the blue but not the red. This area has yellow on the purple but not the red and not the blue. This area has the red but not the blue. This has the blue but not the purple. Okay, only this area has it all. Okay, this is the area that satisfies all 3 inequalities. Okay, it satisfies all 3. It's above the purple line, it's above the blue line, and it's below the red line. All right? So that is the solution area. Okay, one more. Number 11. It's pretty much the same thing. Let me start over with my colors. Whoa, that is not a pen. Okay, fine. Y is greater than or equal to 0. In my mind, I'm picturing y equals 0. So y is greater than or equal to 0. That's going to be a horizontal line at 0, like this. Okay, so there's my horizontal line at 0. But this is greater than or equal to. Oh, by the way, notice it's solid because of the or equal to. And then I'm supposed to shade a little bit on the above side. Okay, so this could, because it's greater than, so that's above, so I will shade a little bit. All right, now for the second equation, inequality. We're doing this one, so gotta subtract x. So that's what we have so far. Now we have to divide by -4. Be careful. Remember, when you divide by negative, you must reverse the inequality. So this is going to go from less than to greater than. And watch what I do with this. 1/4 x minus 1. All right, a negative divided by a negative is a positive. That's why there are no negative signs. But don't forget, treat this like there's an invisible 1 here. So that's 1/4. x. So this is the line I'm graphing now. Start at -1 because of the y-intercept, and then go up 1, right 4. Always go to the right. Okay, so this is going to be a dotted line because of the, there's no or equal, so it'll just be dotted. Okay, and because this is greater than, we are going to shade above this one. All right, for the same reason this one, we also did above. But when we do the shading, we will just shade a little bit above. Okay, just a little bit, like this. Okay, now we have one more line to draw. All right, we'll do this one in purple. There's really nothing to do with this one. Remember that if I had y equals x, this would not be horizontal, it would not be vertical. All right, it's kind of like having y equals x plus 0, where we have a slope of 1 over 1. So this simply means start at the origin, start at 0, 0, and then go up 1 over 1 from there. I'm losing my voice, guys. Gonna have no voice left soon. Okay, this one is also a dotted line, which I can almost just leave it like it is. And then we'll just shade on the above side. No, this is less than, so that's going to be shaded on the below side of this line. Below. All right, so the solution area has to be below this line. Okay, so there are many zones on this graph, but we need to look for the one that satisfies all 3 equations. Okay, and I'm hoping you can see as you look for the area that's satisfies everything. It's got to be below the purple line, so that puts us down here. It's got to be above the red line, so that puts us in here. But it also has to stay above the blue. So you guys can probably shade this better than I can because you have pencils and things that are more precise. But when you draw this, when you highlight this, it's important that you do not go below this x-axis. Okay, because the x-axis, we're supposed to be staying above it. So if you dip down, it does not go all the way down into the V there. It stops at the x-axis. Okay, so this is the zone that you would shade. Okay, and that is it for this assignment. I will see you on the next video. Hopefully my voice will be better by then.